Hi students, this is some tips to help you solving homework number 3. We have in homework number 3 three questions and they are simple. We have a scroll, I think, in the first question. It has a first position and second position. The first position is represented by position vector, which is r1, and this is the magnitudes for I and j. You can see it in as a point, which is 1.3 comma 3.5, and we can write it as a vector. And the second position is, as you see in this vector position. Now we have a time period between the two positions, t1 and t2. We can compute the time period. Part A and part B, you need to compute the average velocity in x direction and in y direction. You have the position initially and finally. Then you can find delta x and delta y, which is altogether r delta r, or delta change in position. And you have the period time, the time period. So you can compute delta x, which is x2 minus x1. Also you can compute delta y, which is y2 minus y1. Then you have also the time period. So you can find the average x velocity and the average y velocity. What about the speed? Simply the speed. You can use the Pythagorean theorem, which is v is equal to vx squared plus vy squared under the square root. And also you can find the direction of that speed, which is tan inverse to vy over vx. This is for the first question. The second question, it is simple also. There's a car, like the action movies, and the driver need to jump from a side of the river to the second side. The first side, its altitude above the river is 20.6 meters, but the second side is lower, not higher. So what is the speed? The initial speed or the initial velocity? We know that using this any car, the initial angle will be 0. So he can jump just in horizontal speed or horizontal velocity. So alpha naught will be equal to 0. So when we see Batman movies, for example, we can see that his car flying this way. We don't know if the car have some mechanism to make it jump with initial angle more than 0. But logically, the initial angle in our problem will be 0. The width of that river is 59 meters. So the safety distance is the river width or wide. Okay, so we need to know the initial speed horizontally. Also the second part, we need to know the speed, which is vx squared, the same like this question, the first one. The speed is the use of the Pythagorean theorem. Okay, now we have two vectors. Mainly we can use them for projectile motion. The first one is position vector and the second is the velocity vector. Now we need to look at the formulas in both vectors and to find which parameters are known and which are unknown. The unknown variables are v naught in both vectors. Alpha naught is known, which is 0. The range, which is the maximum x displacement or x the distance is the range is the river wide, which is 59 meters. We have two altitudes, h1 and h2. We need to find the time because we have the time is unknown also. G is known, it is downward 9.8. So we need to find V naught. We need at first to find the time, which is flying time. Okay, how can we find the time? From the position vector, we can use the y component. The change in altitude, which is h2 minus h1, they are given. So delta y is given, which is h2 minus h1 between the first and the final point. Okay, using the y component, this one, v naught sine alpha naught. Alpha naught is 0. Sine 0 is 0. Sine 0 is 0, but cosine 0 is 1. Cosine 0 is 1. Now we will use this part. We know the change in position in y direction. The change in position in y direction, which is h2 minus h1, we can compute it, which is 1.9 minus 20.6. Now this will be equal to v naught sine alpha naught, which is 0 as we talk, plus half 9.8, which is g, but it is in minus direction or negative y direction, multiplied by t squared. This number is known. This is known. This is known. Then we can find t. This is known. We can find t squared. Then we can find t. Now this is the first step. Now from x component in position vector, vx, rx, I'm sorry, or x is equal to v naught cosine, which is 1. V naught is unknown. T is known from the previous step. It is the flying time. It is the same. X, it is the river width, okay, which is known, which is 59 meters. V naught, we need to compute it. This is 1, this is known. So we can find V naught, which is the same V naught for all our motion, which is horizontally. We don't have V naught in X or Y direction. It is just in X direction. Now, if we need to find the speed, this is the velocity vector. V naught is known. Cosine 0 is 1. Sine 0 is 0. This term will be dropped. G is negative in direction negative 9.8 multiplied by t. T will be computed from before. We can find t. Then V naught is known, t is known. All the velocity vector will be known. We have Vx known, Vy is known. Then we can find the speed, which is the square root of Vx squared plus Vy squared. And phi is the tan inverse of y component over x component. This is the second question. The third one, it is about the relative velocities. We have a train, there is a bicycle or a motorcycle over it. Its velocity with respect to a person, on the ground stationary, is 18. So let us look at this. The ground, I give it Vg is equal to 0, and the person, I name it number 1, V1 with respect to ground is 0. Its velocity is 0. We have the speed of the train, or the velocity of the train, is equal to 13 meters per second with respect to the ground and also with respect to the same person. So V2, the train, I name it by 2. I name the motorcycle above the train by number 3. So the velocity V3 with respect to 1 or to 0 is 18 meters per second. The velocity of the train with respect to ground or of the train with respect to the person who is stationary at the ground is 13. What is the speed of the person with respect to train? Any person standing on the train, he will see this person moving in opposite direction with negative sign, because we have the positive x and the negative x, with the same speed, negative 13. So the velocity v12 is equal to negative v21. Okay, now we need to find the velocity of the motorcycle with respect to the train. The train is 2, motorcycle is 3, so we need to find v3 with respect to 2. V of the motorcycle with respect to train, it is unknown. Okay, we know the relation between different bodies. We will reach the velocity by v32 is equal to v31, which is known, which is 18, plus v12. We know v21, but we can find v12, which is negative 13. Then we can find it will be 5 at the end. But you need to do that by yourself, because you will see that maybe in the exam. This is all about this third homework. Good luck.